This is going to be another video on quick sketches for polar curves. Okay, so quick sketches. Quick sketches for polar curves. So we're going to look at limacons. Okay, so we're going to look at limacons. Right, so a limacon. So limacons are going to be of the form. So limacon is going to be of the form r is equal to a plus or minus b sine theta, or r equals a plus or minus b cosine theta. So these are going to be limacons, and there's going to be certain types of them. So the first thing I'm going to do is going to get GeoGebra up and just have a little play and have a look to see what the different types are. Okay, so here is a limacon. So we've got 1 plus 3 sine theta. So I've got a is 1, b is 3. So this is r is equal to a plus b sine theta. So what you can see is two things. First of all, this has got an inner loop. Okay, so this limacon has an inner loop. Okay, here in red. It's going upwards as well. Okay, it sort of opens out upwards. Okay, so if I make it a minus 3 sine theta, so this is now 1 minus 3 sine theta, it's still an inner loop limacon, but it opens down this time. Okay, so if it's a plus sign, it opens upwards. If it's a negative sign, it opens downwards. Okay. Okay, if I change the a to negative, can you see what happens? Well, it's still a limacon within the loop, but what's happening is the part where r is negative changes. So when a is positive, the inner part is the negative r, and the outer part is the positive r. But when a is negative, it's now the inner part that's positive and the outer that's negative. That's not surprising, really, if it's changing the sign. Okay. If I change it to cosine, then you'll see that it's very much the same thing, except now it's horizontally. So a plus cosine opens outwards. Negative cosine opens the other way. Okay. So these are inner loop limacons. Okay. If I have a positive a, then the green is the out part. If I have a negative a, then the green is the in part. Okay. Now we'll deal with some special cases in a minute, but the first one is we could make now the a and the b the same. So if let me make it 2a, 2. There we go. So 2 plus 2 cos theta. So this is now a limacon still, but it's not got an inner loop this time. So there's no inner loop. In fact, this is called a cardioid. Okay, cardioid. It looks like a heart. Okay, so when the a and the b are the same, it looks like a heart. Again, if I change it to negative, it'll just open out the opposite direction. Signs will open out upwards, or negative signs will open out downwards. Okay, so if I change this to plus, there we go. And finally, if we kind of make it so that a is bigger than b, so here I've got b is 1 and a is 2, then it becomes like a dimple. This is called a dimpled limacon. Okay, so a dimpled limacon is when a is bigger than b. Okay, so this is opening out upwards because it's sine, plus sine, but it's a dimpled limacon. So we're going to look at sketching these now. So let's get to our whiteboard. So a couple of things. There are kind of three types. So there's the inner loop limacon. Okay. So inner loops will happen when the modulus of A is less than the modulus of B. Okay. We then have a cardioid, heart shape, and that's when the mod A and mod B are equal. And the final thing we would have is a dimpled limacon. Okay, so a dimpled limacon is when the mod A is equal to the mod of B. So what I'm going to do is I'm going to go through a couple of quick sketches for each of these. And again, this is supposed to be a speedier thing than what I'm going through. I'm going through at a pace that's kind of explaining at the same time. Okay, so let's have a look first of all at the inner loop limacon. So let's have a look at one of those. So let's have a look at R equals 2 subtract 5 sine theta. Okay, so straight away we've got the mod of A is less than the mod of B. Okay, so this is going to be an inner loop limacon. So what I would recommend then is having a little bit of an axis. So here's our axis. Notice that it's negative here. So it's negative sine. Okay, so what that's going to do is that's going to say, well, if it's sine, it would open upwards. So this negative sign is going to open downwards. Okay, so it's going to be an inner loop limacon that opens downwards. So it's going to have this kind of general form where it's like a loop here and an outer loop here. So let's decide which way round the green part's going to be and which way around the red part, where it's green is where R is positive and red is where it's negative. So if I think about a little table, R and theta, okay, so I'm just going to have a couple of values very quickly. So the values that we're going to think about are just these 0, pi on 2, pi, 3 pi on 2. Pi on 2, pi, 3 pi on 2. Okay, so when R is 0, sine of 0 is 0, and so this just gives me 2. When theta is, when theta is 0, I should have said. When theta is pi on 2, sine of pi on 2 is 1. So this becomes 2 take 5, which is negative 3. When theta is pi, sine of pi is 0, so this becomes 2 again. And when sine of 3 halves pi is negative 1, so this would become 2 subtract negative 5 times negative 1. So in other words, that would be 7. Okay, so notice that we've got on 0 and pi, we're going to have the same value, and they're positive. And notice as well here that these 7, okay, we've got half here. When it comes pi on 2, sorry, it's at pi on 2, it's going to plot downwards here, because remember R is negative, so it's going to kind of plot downwards. So at pi on 2, it's going to be negative 2, and then at 3 pi on 2, so when we've turned all the way around to here, it's going to do the full 7. So that tells us that the outside loop is the, so we're going to have something that looks a bit like this. Excuse the drawing. It's going to come around like that. And then for the inner part, those are the negative R. There we go. So looking something like that. So here we've got, this is going to be 2, 2, 7, and 3. Okay, so you can almost imagine as as the angle is theta equals 0 increases to pi, what's going to happen is it's going to come down, down, it's going to go down, 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 round here, out and back round. Okay, so this is the first example that we're going to look as an inner loop limacon. So the general method will be is 1, identify the type of limacon, whether it's inner loop, cardioid, or dimpled. So identify the type. 2 is get the direction and the axis. So here it was sine, so it's on the up and down axis, if you like, or the pi and 2, 3 pi and 2, and the direction with the sine. 3 is a quick table, so this is quick. It's supposed to be quick table, and then 4 is sketch. And I think it's important to decide where the red and the green is. Okay, so let's do another example. Let's do R is equal to 3 plus 4 cos theta. Okay, so again, if we look, the mod of 3 is less than the mod of 4, so it's an inner loop. So we can imagine a sort of picture already. It's plus cosine, so it's going to open out in the positive direction on the cosine. So we just need to know what the values of the pieces are now. So in a quick table, and the only values you need are 0, pi and 2, pi, and 3 pi and 2. So 0, pi and 2, pi, 3 pi and 2. Okay, so when theta is 0, cos is 1. So this becomes 7. When theta is pi and 2, cos is 0, so this becomes 3. Likewise at 3 pi and 2. When theta is pi, cosine is -1, and so 3 take 4 is -1. Okay, so that's telling us where the inner part is. This negative is going to tell us where the inner part is. So if I have a sketch now, it's going to open outwards. It's going to open outwards, and at pi, at the angle pi. So when it's turned out here, it's going to be a -1. So it's going to be coming in here like this. So the inner loop is the negative part here. So it's going to look something like this. Excuse the drawing. The inner loop, and then we've got the outer loop like this. Something like that. So we've just worked out that when it's 0, we've got 7. When it's pi, so when it's turned to here, then it's here. So it's going to be 3. We've got, sorry, -1 even. So that'd be 1. Okay. And here we've got the 3 and 3. 3 and 3. So there we have our inner loop limacon. Let me do another example. So next example is going to be R is equal to -2 plus 3 cos theta. Okay, so again, modulus of -2 is less than the modulus of 3. So it's an inner loop limacon. Okay, so an inner loop limacon. It's plus 3 cos something, so you can imagine it's stretching out to the right. Okay, we just need to know the details of the table. Same table every time for these. So we're going to have theta r 0 pi on 2 pi 3 pi on 2. Okay, so when theta is 0, sorry, cos is 1, so this becomes 1. When theta is pi on 2, cos is 0, so this becomes -2, and likewise -2. When theta is pi, cos is -1, and so this becomes -5. So hopefully you can see what's going to happen here. It's going to draw a very similar one to last time, except this time the red's on the outside. Okay, so we've got the inner loop part is the positive values of R, and then the outer loop is going to be the negative values of R. So something like that. So we've got 2, 2. This would be 1 and 5. Okay. So strictly speaking, what's happening here, as that negative, when it gets to pi, so as it's rotated to here, then it measures it backwards, or strictly speaking, adds on a pi and plots it. Okay. So that's the those are the inner loop limacons. Okay, so the cos part, that tells you which axis. So cos theta is the x-axis. Maybe I shouldn't say that. Maybe I should say the initial line. The sine theta is going to be the pi on 2 axis, just to distinguish. The plus or minus is which way it opens. And then always draw a table. Okay, so those are the inner loop limacons. The next thing that we could be looking at are the cardoids. So those would look like this. Maybe if I have r equals 2, subtract 2 sine theta. Okay, so here the mod of A is the same as the mod of B, so it's a cardoid. Okay, so we know that it's going to be some heart shape. The negative is going to tell us it's going downwards. Well, the sign tells us up or down. The negative is down. So it's going to look something like this. It's going to be a heart shape like that. The question now is it green or is it red? So what we'll do is a little table just very quickly to find that out. So for theta, we've got theta is either 0, pi on 2, pi, 3 pi on 2. So that's r. Now, when theta is 0, sine is 0, so we'll have 2. When theta is pi on 2, sine is 1, so this becomes 0. When theta is pi, sine is 0, so this becomes 2. No, it doesn't. It becomes 0 still. Yep. Sine of pi is 1. No, sorry. Sine of pi is, what am I talking about? Sine of pi is 0. So 2 times, so that's 2, sorry, it was 2, yeah. And finally, the last one is when sine of 3 pi on 2 is negative 1. So that's going to become 2 subtract 2 is 4. Okay, so it's going to become 4. So this is all positive. So it looks like we're going to end up with something like this. Okay, so we've got the 0 and the pi. So here is the 0. Here's the pi. We've got the 2. We've got the 0 and the 4. So this would be down here at 4. Okay, I'll tie that up a little bit. Okay, there we go. So again, because mod A is equal to mod B, then that says it's a cardoid. Because it's sine, it's the up and down axis, if you like. Because it's negative, it opens downwards. If we draw the table, we find that everything is in fact positive. At 3 pi on 2, sine is negative 1, so this becomes 2 subtract negative 1 times negative 2. So this is going to be plus 2. So 2 plus 2 is 4. Okay, so it's all positive. Okay, I'll do another example of this. let's do r equals 1, 1, subtract cos theta. Okay, so again, mod A is equal to mod B, so it's a cardioid. So we've got the general shape. Because it's cosine, it's on the x-axis, if you like, the cross-axis. Because it's negative, it's going to open left. So we've got the general shape in our heads. Let's just find out whether it's green or red. So if we've got theta and r, 0, pi on 2, pi, 3 pi on 2. The cosine of 0 is 1, so 1 take 1 is 0. Cosine of pi on 2 is 0, so that would become 1 take 0 is 1. The cosine of pi is negative 1, so this would become, cosine of pi is negative 1, so 1 subtract negative 1 is 2. The cosine of 3 pi on 2 is 1 subtract, well, cosine of 3 pi on 2 is 0, so 1 take 0 is 1. So we've got this situation here. These are all positive, and so we're going to end up with a shape like this. That's green. It's going to open out like this as a cardioid. There we go. We know that this is going to be 2. And these are 1 and 1. At pi on 2, it's 1. At 3 pi on 2, it's 1. When it's 0, it's 0, and when it's pi, it's 2. Okay, so it looks like that. So that's the cardioids done. Well, the other case that we've got now is we had, for the inner loops, we had mod A is less than B. For the cardioids, we had them equal. So for the dimpled limacons, A is greater than B. So let's have a look at an example of that. R is equal to 3 subtract 2 cos theta. So here the mod of 3 is greater than the mod of 2, negative 2, how you want to look at it. So this is now saying basically that this is a dimpled limacon. So a dimpled limacon. So we just need to get a table now. So the table is going to have the same just key points on this. We know the general shape, we just want a couple of values on it now. So that's theta r 0 pi on 2 pi 3 pi on 2. When theta is 0, cos is 1. So this becomes 3 take 2 is 1. When at pi on 2 and 3 pi on 2, cosine is 0, so this becomes 3. And finally, when cosine of pi is negative 1, so this is going to become 5. So all positive, we just need to draw it now. It's opening out to the left because of the negative here. So it's going to look something like this. So it's going to cross here at 1, it's going to cross here at 5. So it's going to come and do maybe a little dimple. So come out, dimple, and then back. Okay, maybe I'll do a little bit better than that. So it's going to come in, dimple, and out, where this is 5. On the axis here, we've got 3 and 3, and this is 1. Okay, so that's a dimpled limacon. Let's do another one. Okay, so let's do r equals 2 plus sine theta. So again, mod of 2 is greater than mod of 1. So it's a dimpled limacon. Okay, so dimpled limacon. It's opening upwards because of the sine plus sign, so we know that it's kind of doing this kind of an egg shape. We just need the values now, so we just need a quick table. So the more of these you do, the quicker you do get at them. As I'm sort of explaining them less and less, I'm getting a lot faster at them. So, and I expect the same for you. So once you've done a few, if you just do one, obviously it'll take you some time, but the more that you do them, the more you'll get speedy at them. Okay, so I've just filled in a table for you. Obviously when theta is 0, sine is 0 is 0, just like 2, and so on. So this is going to open upwards and it's dimpled. So it's going to look something, if I can, like this. So it's got the bit there and it comes and dimples and comes out like that. There we go. So we've got the key values then of, up here would be, well, on the axis it's 2. This would be 1, this would be 3. Okay, so we've done the limacons now, the dimpled limacon. We've done the, well, in fact, let's summarize. So there's 3 types of limacon. Okay, and the first type is the inner loop. That's when the modulus of A is less than the modulus of B. And here we've got R is equal to A plus minus B sine theta, or R equals A plus minus B cos theta. The sine or cos is the axis. The plus or minus is the direction. The table tells you the color. So is it red or green? Or more precisely, R greater than 0, R less than 0. Okay. You have a cardioid, heart shape. If A mod A is equal to mod B. Same as above though. And thirdly, we have the dimpled limacon. The dimpled limacon will be when the mod A is greater than the mod of B. Okay, so dimpled limacon is mod A greater than the mod of B. Okay, for the inner loop in particular, really do pay attention to which parts are green and which parts are red. Okay. Right, well, I'm going to end this video here, and I'm going to do one more video, which is going to be on the lemniscates and circles. I'm going to group a few of them together next. I'm going to end this one here.